Hello everyone. We are going to tackle flame cutting practices, chapter 6. Today's lecture starts in 171, relatively short chapter. Just going to hit some highlights out of it. We are pairing it with chapter 5, which really went in depth to some of the gas metals and the basic concepts and so forth of oxy-fuel welding. So we're going to start on this. Okay. Not much difference, a little bit different apparatus is all. Universal tool, used widely for straight line shop cutting, means of scrapping obsolete structures. I've talked to people all across the world, and of course plasmas are really nice. They're quick, but you have to have a power source and you have to have an air compressor, right? Every school I've ever went to and almost every business I've ever been to, the one thing that is in every one of their shops is an oxyacetylene cutting torch. Okay, no matter what, if it's carbon, and you can even cut stainless with it as well by using a waster plate and so forth. But you can use it to cut a wide variety of things. It can be used to heat, cut bolts, old parts off, maintenance, repair. Just a widely used piece of equipment. Very important. And again, it's something that if you can use this, just like welding with shielded metal arc welding. If you can weld with it, you can usually weld the other ones fairly well. If you can cut this with an oxy-fuel torch, know the preheat, understand the concepts, practice to where you're really good with the torch, plasma torch is easy. It really is. So let's learn the harder thing and accept the simpler concepts as well. Okay? So, oxyacetylene is the main fuel that we're going to be concerned with, especially in our shop. There are other fuel gases as well. Okay. Limited to cutting ferrous materials. You can use a waster plate to cut stainless, even though it has a small amount of carbon. It can be very difficult to do. Okay. Arc or water jet processes, stainless steel, magnesium steels, non-ferrous materials, mechanical methods of cutting, grinding discs, saws, and so forth. The oxygen cutting requires that the part to be cut be raised to a temperature of roughly 1600 degrees, so it's good and glowing orange. Then you're going to hit your pure oxygen. It's going to support combustion to a very high rate, gives off iron oxides as a product of combustion, melting point below the melting point of steel, so iron oxide runs off as molten dross, exposing more iron to the jet. Okay, so this is where you're going to get some slag on the back, dross, so forth. The dross is the actual, slag is the byproduct, which is not metal. Dross is actually the product that contains iron on the backside as well. Okay? Some of the properties of the fuel gases. As you can see, looking at the neutral flame, temperature variations we talked about in chapter 5, acetylene is the highest. The equipment needed, the cutting torch. Talked about this quite a bit in number 5, chapter 5 as well. You got an oxygen head that's separate, or an oxygen line that's separate. It doesn't mix, they are contained different. That is the one different characteristic between the oxygen torch and the welding torch. Is your oxygen comes out its own orifice, it doesn't mix in the same tip. When you're welding, you have individual lines, but they join together in the same brazing tip, or in the same tip, the welding tip. Here, they do not combine until they're in the atmosphere. Okay? Kind of one of the biggest things to understand, I think, about oxyacetylene cutting tips and welding, and I'll take you through a personal demonstration for it as well, and we have to. But when you're looking at the end of the cutting tip, okay, you have a center piece, and then you have several exterior holes in there as well. Your center is your oxygen. Okay? All your exterior ones are your fuel gas, and this in most cases acetylene. Okay? You also need, we'll get you the Victor book in there. I want you to go through, I want you to read through it at the same time as this PowerPoint presentation and understand the difference between the types and the sizing of the tips. So sizes go from aught, triple aught to I think 15, just like in the oxy-fuel welding process. Very similar to gas welding, except for now we are removing material instead of adding material. As you can see here, here's a good example of the cutting tip. Right there in the center is the oxygen, so forth. No matter what you do, make sure you use the correct wrenches, okay? Don't put channel locks on these. These torches are very expensive. A decent one's about $300, $350. There we go. There's the breakdown. Oxygen in the center. The exteriors are your fuel gases. Cutting oxygen orifice size not usually affected by the type of fuel gas used. Various fuel gases require different volumes of oxygen and fuel. By far, if you're switching between like propane or polypropylene or a MAP gas to acetylene, the one thing you have to understand is that they're different fuels. They're going to use different pressures, and to make sure that your regulators are the correct ones as well. Okay. So, several different tips here. You can use some for gouging, some for scarfing. This is what we use in the shop for a scarfing type tip. You can get an elongated cutting tip. I've got some that are 8 inches long to get in like a bore pattern. There's a sheet metal tip, so forth. Okay? Some good information in this PowerPoint. Lighters. Biggest thing here, never use matches. Don't use a Bic lighter or a normal lighter. Make sure you're using the proper friction lighter or electronic lighter designed to ignite an oxyacetylene torch. Okay. Number 5 minimum, shade on the lenses. Okay. Whether it be goggles or a face shield or even your normal welding hood, make sure number 5 minimum. Do not just put normal sunglasses on. You might get away with that for a little bit, but it's still doing damage to your eyes, okay? Make sure that you're wearing good heavy gloves as well. There are several different types of squares and straight edges that you can use to help aid in cutting straight lines. Good example. This is a track torch. Okay, this is a much smoother way to cut than if you or I to be trying to cut a straight line on our own. We have a mechanized system. We set the torch, we wait for it to preheat, we'll turn our oxygen lever on, and then you can start cutting from there. We will show you this as we're in the shop. Alright? Great piece of equipment. They're larger units for sure. Automatic controlled, CNC controlled type systems. So you can see this is oxy-fuel system cutting several of them out at once. Now we see this more in line with the plasma arc cutting as well. You can get tracers, magnetic eyes, so forth, to be able to follow. You can cut very thick pieces of material with this. Sometimes it takes a great deal of patience. Okay. I have personally cut 7-inch thick iron with an oxy fuel torch. Just with plain oxyacetylene, a number 7 tip. Took me a little bit. Had to preheat it, kind of get going. Watch how my flow's going. 7 or 8 tip. Large unit, but it can be done. This is an oxygen lance system. This is a consumable piece of material. So basically this is your welding rod, but inside of it is hollow, and you're blowing oxygen through it. Okay? So it's kind of like a 70-18 rod with oxygen going down the center. These work really well in lancing out like pins and so forth on the Caterpillar to put two pieces together. If you have a pin that connects them, you go through the center, you'll bore a hole out all the way through it. Then you can stress relieve it, put a piece all thread through with a hydraulic power ram on it, pull that pin out, remove it from the piece of equipment. These are a very valuable tool. I've used this a lot. It can be very hot and very nasty and very dangerous. However, they work really well as long as you think about where your metal is going. Not all of them are made of straight black iron pipe either. I've had copper ones that were solid tubing. I've had rolled pieces as well. And nowadays you don't have to preheat the lance to a cherry red. It just runs off of a straight welding arc. You set it up just like running 70-18. Negative on one end and then a positive lead in this. Alright, any questions? Read through the PowerPoint and the book. Come talk to me. Let's get the Victor book out as well. We will talk about tip sizing and so forth moving on. Thank you and have a good day.